reds and yellows, and greens would be high values, the teal would be sort of intermediate values, blue, dark blue, very low values. On the right-hand side, those little thumbnails have been dropped in to show the locations of the coal-fired power plants in the United States. Do you notice any correlation? So nitrogen dioxide is sort of a nasty pollutant that you really don't want to breathe. It triggers acute respiratory problems. Thank you. In humans and animals, it contributes to the formation of acid rain. So I just want to note the correlation both with the location of these coal-fired power plants in the eastern seaboard. Also note the correlation with topography. For example, there's the Appalachian Mountains here. You notice it's very low values. You'll see a very similar phenomenon at the foot of the Himalayan Mountains or at the foot of the Alps in northern Italy. The pollution just pools up where it's not allowed to disperse, and so it just continues to build up, continues to build up. So those are some of the most particularly polluted airways on the globe. And so using these technologies and having this ready access to these geospatial data sets allows students and teachers, decision support managers to interact with the data and to explore the relationships of natural processes and human processes in a very interactive and visual way that was not possible very long ago. Next slide. So I'm going to say a few words about Earth System Science at NOAA and NASA. Very simply, the objective is to understand our planet and take a very holistic approach to studying the planet. How does the atmosphere interact with the solid Earth and water and all together with life to define and encompass this whole climate system that we know? So it's sort of a very simple representation. The goal is not to zoom in any longer on any individual niche like meteorology or marine biology and treat it as if Mother Nature was compartmentalized in these sort of disconnected niches, but rather to observe and understand and begin to model all the interrelationships and teleconnections that work in the climate system so that we can better understand and predict the future course of the climate system if any one of these spheres were to change significantly. And as we know, as I illustrated earlier, humans are driving these spheres to change significantly in terms of the chemistry of the atmosphere and so forth. Next slide. So just a snapshot. Today, NASA flies some 14 Earth-observing satellites to measure and observe the planet more comprehensively than we ever have before. We support over 800 scientists in the United States and abroad. We flow data into 7 archive centers around the country, and we have at least 15-year mission to meet 24 measurement objectives on a global scale. We're collecting petabytes of data that are available at low cost or in many cases freely. And so the idea is, how can we build and what would they look like, both technological and cognitive bridges to allow non-scientists to access these data and turn them into information and turn that into knowledge in action, which starts to transition over to NOAA. That's NOAA's charter. Next slide. So many of you are probably already aware that NOAA has a responsibility to track and monitor and be involved with studies of coastal and estuarine ecosystems. We routinely monitor the weather and movements of water. We have the National Weather Service. We're involved in commerce and transportation. And now recently, NOAA has formed its Climate Program Office, which is where I sit. And the goal now is, and there is legislation pending, next slide, to establish a national climate service. And so the idea, and in the pending legislation, NOAA would be tasked to establish and lead this new national climate service. The idea is that it would be a cooperative effort involving all of our partners, NASA, EPA, Department of Energy, Department of Ag, and so forth, USGS, to engage with us. But the idea is to bring them together and to begin to develop a cooperative approach to sharing all this wealth of data and information that the agencies are collecting. And so as our vision and our mission statement, but again, the idea is to flow this information very discreetly, very accessibly to society at all levels of society where it's needed in ways that it's needed. It's like. So I want to sketch out very briefly a few of our goals. Again, I could go into much more detail than I have time for today. But the idea is to begin to develop a tailored approach to targeting very specific segments of society, thinking and identifying what are their needs, wants, and expectations for this information. For example, I talked about the informal education community in these museums and science centers and their need for getting access to these geospatial data, projecting them on the globe, and producing immersive environments for education and so forth. And so the idea is to begin to map out solutions that serve segments of society. There's a whole other spectrum that is designed to get these data into the hands of decision support specialists. We're working to establish an amateur Earth observation network, somewhat analogous to amateur astronomy, to engage at a grassroots level and raise the level of attention and accessibility and engagement with citizens worldwide, and to begin to inject Earth system science as part of the K-16 curriculum. So ultimately, the goal is to grow the number of climate science literate citizens at all levels of society. So I once saw a presentation in which one of the most profound things said throughout the whole day in this workshop was an information manager, an IT manager specialist, and he opened up his presentation, and I knew right away I had to steal that saying. It was, "May all your problems be technical in nature." That technical problems can be solved. What are the hard problems? What is the point of this proverb? The human problems. Okay? And so the idea is to know your audience, to know your objective, to know what are the mental folders that your audience has, what are the defense mechanisms they may have in place. Climate science in particular is a very politically charged subject. And so if you want to communicate with people, if you want to share information, get it into their hands in a usable way, you got to solve the human problems first. Work with them to solve the technological problems. Next slide. We've taken one approach. NOAA and NASA are partnering. We've created a new website called NEO for new and NEO for NASA Earth observations. There's the URL. I wish I had time to show it to you. It exists already. It's at neo.sci.gsfc.nasa.gov is where the server lives. But it's a site designed for designers. The idea is to give you access to these geospatial data sets, some of which I've been showing, so that you can work within the tools that you already know, for audiences that you already know, whether you're an educator, communicator, exhibit developer, publisher, etc. Next slide. That's what the interface looks like. Here's just a couple of screens grabs I made very quickly, so you can pick different parameters you may be interested in. So I may be interested in ocean data sets, so I click ocean, select the sea surface temperature, and there's a false color map with a color bar. I can bring that down in color or grayscale if I want to devise my own palette, if I'm working with colorblind people, for example. So it's a highly tailorable, malleable interface. Next slide. So I consider NEO to be sort of variable functionality spokes. We couple up with the instrument teams. We identify the data products of interest. We put into place automated mechanisms for harvesting data products and bringing them into this middleware resource. And then we've got functionality spokes. So you can query and retrieve via a web app service. If you have that, we've got multiple vectors for research, for search and retrieval of the data, looking at different regions, for example. You can view, resize, recolor, or reformat on the fly. You can get and save images locally. You can export directly to Google Earth or other geo browsers. We have our own Java-based analytic tool called ICE, or the Image Composite Explorer, that allows you, I'm going to show you another shot of that, to literally analyze these data in your web browser. So educators can wrap inquiry-based lessons around these data sets, utilizing these data sets to teach students about Earth system science, cause and effect relationships at work. You can use it as a way to browse and go back and get matching data in hierarchical data format. I make the assumption that users don't want to have to learn a new data format. They don't want to have to learn to use a new tool. You shouldn't force them. You should give it to them in a format they already understand and work with, into tools that they're already proficient with. And so you can also bring these data into Microsoft Excel. Next slide. So here's a snapshot of the ICE tool. I've brought down 3 data sets, temperature, chlorophyll concentration, and bathymetry. And I've drawn a little line transect here, and you see those unit values for all 3 of those parameters graphed out. This was done in my web browser. I can also download that in a bundle and have that stored locally. if internet accessibility is a problem in my classroom, I don't want to roll the dice and hope the internet's behaving that day. So I can download it, have it stored locally, so students come in and log on and get right to work. Here's the rainfall map, color bar and branding. This is a map showing you where and how much rain fell over the earth, exported into Google Earth. It's a one-step process. Next slide. So remembering then that technical problems are readily solvable, let's talk about the human problems. The late Jean Maillet, who I really admire, once observed that the mark of a scientifically literate person is not a measure of what you know, per se. In subjects as robust, as deep and wide as Earth system science, who could know it all? And so what are you required to know? And so his viewpoint was that it's not so much what you know, but that you understand where and how to gather information, and that you understand how to discern credible and non-credible sources. Again, thinking about the fact that there's exponentially greater information at our fingertips over the internet today, and people are free to publish whatever they want. And so what are we doing to help citizens discern credible from non-credible sources? Next slide. And so that's just a look at how I like to tackle problems of communication. I think the first question you should ask is, who are you trying to communicate with? Why? Then, what's the message? Too often agencies like to start right here. Here's what I need you to know about us. And usually, the general public or other audiences, they don't think that way. They don't have that mental folder. They don't think in terms of agency org charts. And so, step one is to get to know your audience. Why do you want to communicate with them? Then think about what they're capable of understanding and interacting with, and then process the media. Next slide. This is a simple model of society that's sort of broken out, because this sort of comes back to how are we going to communicate with society in different segments and why. I talked about a discrete, focused approach. So down here, I think in terms of a public continuum, residual public refers to people who are unaware and or uninterested in what we do. Less than 1% of the American public knows NASA does Earth science. No clue about our Earth science program. Most of them also have never even heard of the agency NOAA, much less what NOAA has to offer. And so how do you start off by communicating an org chart or what it is you can do for them if they don't even have the mental folders ready? So the idea is to zoom in very specifically and think about why you want to communicate, what is your objective. I've color-coded those audiences that are relevant to science policy. No others, in my view, are. And in the review of the researchers who looked at that, I also color-coded in green audiences that by far away most agencies tend to target. And I'm not saying any one of these are good or bad, but again, it's just sort of illustrative of what is it you're trying to accomplish and why, if you want to. And so down here, one of our aims is to elevate people up a continuum from being unaware and uninterested to get them being interested. And once I get them interested, I want them to become attentive. And by definition, attentive means you are a heavy seeker and consumer of this information. You consider yourself knowledgeable, and you generally participate or are willing, knowledgeable enough to participate in policy-relevant dialogue. Okay, so what can we do that would elevate you up that continuum and so forth? Next slide. This is some research based on work by John Miller, professor formerly at Northwestern and Michigan State. Drawing from other research as well as his own, he's developed two white papers recently. One was published at AAAS at this year's conference. About 1 in every 4 adult Americans are not functionally literate. I was stunned to learn that stat. Meaning they can't process a bus schedule or the instructions on a prescription bottle. Okay? And about 28% are what he would identify as scientifically literate. And he has sort of a benchmark. They can tell you what a molecule is. They can tell you certain basic scientific concepts. This number is up from about 10% since 1988. And so over the long term, the good news is we can make inroads, as it seems, into science literacy. And so in between those two extremes is sort of a bell curve of the rest of the population as to where they might fit on that literacy spectrum. And so I mentioned earlier, then I view it as sort of many audiences, many levels of engagement, and I think we need to be thinking very discreetly in terms of how we have that engagement. Next slide, I've already made that point. I think in terms of developing examples programs of best practice, where you have sort of a three-legged stool model, led by the audience expert who owns the interface with the audience, subject and a medium expert, and the feedback loop, and then think in terms of amplifiers. I thought that might resonate with this community because it seems to me that if we hit a sweet spot in terms of communicating with or educating a segment of society, we're going to immediately want to start to think in terms of how do we broaden and amplify that? How do we get that into more and more people's hands? How do we take that to a tipping point? If some of you have read Gladwell's book, in terms of, and I think Internet 2 would be a very useful partner in that. And so with that, just sort of wrapping up, I want to conclude with just some thoughts. I would like to explore some sort of partnership that we might develop with NOAA and Internet 2 to explore possible pathways to deliver the climate science data, to think very discreetly about segments of society, whether we're trying to flow these data to food growers, decision support managers in terms of insurance and reinsurance, in terms of coastal management and so forth. So operational scientists down to educators and students. Again, coming back to the other point I raised, I think there needs to be some sort of a mechanism that indicates, or some sort of a filter that only allows peer-reviewed, credible, verified scientific information. I think that would be a very useful way to combat the problem of misinformation that exists, particularly in the domain of climate change, climate science, and global warming. As I alluded to earlier, we are now getting just huge volumes of data. If you were to take all the data coming from NASA's Terra mission alone and print it on CDs, okay, for 1 year, you would have a stack 2 times taller than the Empire State Building. Okay, so a tremendous amount of data. And so it seems to me that we also need to be thinking, and I'm sure you already are, and we have a lot to learn on this front, but NASA and NOAA need a partner like Internet 2 to be thinking and identifying ways of allowing users to get at these huge volumes of data, sift through it, make sense of it, and begin to turn it into knowledge and action. So I know I've gone very fast in limited time. If there's any time for a question or two, I'll be happy to entertain.
Let's take a couple of questions.
One real quick, what was the rest of that, NEO's side GC?
Yeah, neo.sci.gsfc for Goddard Space Flight .nasa.gov. And there it is.
Thank you.
And you're certainly welcome to distribute this presentation so people can have that.
We'll post the slides on the K20 website. Any another question?
Yes.
On your NEO site, is NASA posting the data or is NOAA?
Well, they reside on the NASA server. NOAA and NASA partner together. It was initiated by NASA. There are NOAA data sets in there where we have plans to add more. For example, we're about to
The
add.
issue is NOAA is very well known for not having persistent data sets. We're only leaving data up for a certain amount of time and then burying it in the data archive. If you create this point, are you going to have a policy of keeping the data up so that like a 9-month curriculum will find the data the next time they go back instead of what we have every time we come to hurricane season and we can't find last year's data?
Yes, and not only do we have a policy of keeping it stable and keeping it permanently available, but we are beginning to also look at and explore partnering in such a way as to mirror the site. That might be another way to alleviate some.
I'll volunteer right now to mirror any site.
Love to hear it.
Are you familiar with the Scoop project?
Scoop?
Yeah.
No.
It's a NOAA-funded project. We mirror a lot of sites already. I'm from Texas A&M, and I'm actually dead serious. I'll mirror those sites.
We have, we're working, for example, on one prototype initiative to take all the MODIS data and begin producing 2 daily global snapshots of Earth at 250-meter resolution, 2 each in true and false color. There's no way we have the ability to host and serve that on NEO. And so we're building a relationship with the San Diego State University Supercomputing Lab. Some of you may have John Brand there to set up the ability to host that.
He has funding to host it. We host stuff there right now.
Yeah.
We keep 30 terabytes online, spending all the time. So the amount you're talking about is chump change right now.
These data sets, it's not as big, but you know, that number of global images at that resolution starts to add up. And the other issue is serving them in a responsive way. When we published NASA's Blue Marble, my team that developed and published this Blue Marble image of the Earth at 500 meter resolution, it brought down the NASA guided network. It brought down the state of Alaska's network. When we started serving it, it's just through popular demand. So if you're thinking of ways to host and serve it in such a way as to not adversely impact the network.
10 gig big enough?
Pardon?
10 gig big enough?
I hope so.
I'm actually very serious. A lot of people really know me. And I'm very serious. This is something that we're extraordinarily interested in. And you know, I'll lay the challenge on the table right now.
All right. Thank you.
Thank you, David. As Larry